Okay, so
Hi,
here we
so we
created an
decided to do our
example
sinusoidal
problem,
project
and
on a
it's
toy
a sticker
unicycle.
is on the tire of
The first
the
step in
unicycle,
understanding a
which we did
sinusoidal
in
function
our
is looking at
diagram.
our rules
And
for our
then
special right
the
triangles.
sticker
So
starts
over
at
on
the
the
ground
left,
height,
I've
and then our question
drawn
is
both
how
of
far
these.
from
One
the
is a
ground
45,
will the
45,
sticker
90
be after
triangle,
the
and one is a
unicycle
30,
travels
60, 90
12
triangle.
inches.
This
And
basically tells
so
us
to
that when
find
the
this answer,
hypotenuse
you can
is
just plug it into the
1 in one of these
calculator,
triangles,
and you
we
get an
know
answer
that
of y
the
equals
legs for
2.5.
45, 45,
And you
90
can see
triangle
that
are both
because
root 2 over 2.
once
And then
the
for a 30, 60, 90
x-axis, when you go to
triangle, we know
12, so
that
if you
the
think like
shorter
the
leg
tire traveling
is
like 12
1/2
inches
and the longer
across,
leg is root
then
3
the
over
height of the
2.
sticker would be at
We can then
2.5,
apply
which
this to
makes
the
sense in
unit
terms of
circle,
like our
where
graph.
we draw these special triangles starting from the origin of the circle out to the outside. With this information, we can find the coordinates of when the hypotenuse touches the edge of the circle. So we have those drawn in right here. Then we know our special ratios for sine, cosine, and tangent. For sine, for example, it's opposite over hypotenuse. So in this case, if we are looking at the line drawn with a 45-degree angle, we know that the opposite side is root 2 over 2, and the hypotenuse is 1. So sine of 45 would be root 2 over 2. So in order to simplify this, we know that sine is always going to be equal to y, and cosine is always going to be equal to x. And we've halves represented graphically below.
Okay, so each of the graphs you can correlate with a equation, and that would be y equals a sine bx minus c plus d. And then sine and cosine you can use interchangeably. So the A represents the amplitude, which is the value from the midline to the maximum, or the midline to the minimum. And then, as you can see here, like this is a normal one, and then when we changed the A to 2, it increased. And then B is the frequency of the period, which represents how often like one cycle will occur. And so for here, like this one is just a normal one, because for sine it'll go from 0 to 2 pi, and then for like the cosine you can see it goes from like the maximum to the next maximum. But then when you change the b value, then it can either compress or it can stretch out. And then the c represents the phase shift, which is left or right. And so here's like the normal just sine function, and then if you move it over, the graph will move over left or right. And then D represents the vertical shift, and so that's just increasing from or decreasing from the midline. And as you can see here, this is normal at the midline, and then it increases by 2, so the midline will change.
Our sinusoidal relationship is between the distance that a unicycle travels in inches and the height that a sticker that we placed right on the tire, the distance it is from the ground as it moves.
So before creating our model, we created a data set, and some of the information that we used was the height of the tire, which was 5 inches, the radius of the tire, which is 2.5 inches, and then the circumference of the tire, which is a total of 16 inches. And just for like future equations that we'll create, we needed to know that the circumference was 2 pi r.
Our first step in creating our model was to cut out a perfect circle using a compass to represent the tire of our unicycle. So because we had determined that with our data set that the radius was 2.5 inches, that's what we set the compass to, so that the full diameter would be the 5 inches. After that, we constructed the road for the unicycle to drive down, and we specifically made sure that it was raised on either side so that the tire rotated in a uniform way so that our data was correct. We then measured the length of the road. That way we could determine how many inches it took for one complete cycle of the wheel to rotate, as well as the height, so that we could visually show the distance the sticker was from the ground. As we moved our wheel, we also created a representation of the height behind it with string. This is similar to what our graph is going to look like. It shows that as the wheel moves, the sticker is going to get higher until it reaches its maximum point, and then it's going to decrease until it's at its minimum point.
Okay, so to create our equation, we used the measurements from our data. And so we knew the height was 5 inches, and in order to find A, you do max minus min divided by 2. So that's 5 minus 0 because the minimum is at ground level divided by 2 to equal 2.5. And then to find the b, we did 2 pi over the period, and the period is 16, which we know because the circumference of the tire was 16. So that means it would travel 16 inches. And so we did 2 pi over 16 to equal pi over 8 for our b value. And then there's no c value because we started at the minimum in our diagram. And so we left that out. And then for the d value, it's the midline. So you do the max plus the min divided by the 2. So 5 plus 0 divided by 2. So it was also 2.5.
Our original equation is negative 2.5 cosine, and that's because usually a cosine function starts at its max value and then decreases before increasing. In our case, it was starting at 0, which is the minimum value, and then it was increasing until 5. So that made it a negative cosine function. However, below here we created 3 other equations, which are all equivalent. They create the exact same model. So one of them is we made the amplitude positive 2.5, but in order for that to work, that meant that our maximum value had to be at 0, which accounts for the shift. So earlier Morgan described how we did not have a c value because our function started at the min, but in this case we would need to have it shift 8 to the left, which is why we have the minus 8 value. But the d value and the b value as well as the a value remain the same for all the functions except for being positive or negative. Our last 2 functions are both sine functions. So for the first one, we still had the 2.5 sine and the same b value. However, we subtracted 4 because sine functions start when the x is 0, the y is at the midline. So in our case, if we were to shift 4 to the left, that would mean that the 2.5, which is our midline, would be at when x is 0. For our last function, we made sine negative 2.5, and we shifted it over positive 4, which means that it was moving instead of to the left to the right 4. And usually in a sine function, it goes up first and then it decreases and goes down. But when we made this horizontal shift, it went down first, which is why we had to make the amplitude negative.
Okay, so here we created an example problem, and it's a sticker is on the tire of the unicycle, which we did in our diagram, and then the sticker starts at the ground height, and then our question is how far from the ground will the sticker be after the unicycle travels 12 inches? And so to find this answer, you can just plug it into the calculator, and you get an answer of y equals 2.5, and you can see that because once the x-axis when you go to 12, so if you think like the tire traveling like 12 inches across, then the height of the sticker would be at 2.5, which makes sense in terms of like our graph.